Okay, hello Cloud Gurus and welcome to this lecture. This lecture is on elastic load balancers. So what is a load balancer? Well, surprisingly, a load balancer is exactly what it sounds like. It is a physical or virtual device that's designed to help you balance the load, balance the network load across multiple web servers. So here we are, we've got a load balancer. Here's web server 1, web server 2, web server 3, etc. And it can balance the load across the three of them. You can also use it for applications. It doesn't have to necessarily be internet-facing load balancers, but typically they are internet-facing and primarily they're used to balance load across web servers. So with AWS, there's three different types of load balancers. We've got our application load balancer, we've got our network load balancer, and we've got what's called our classic load balancer, which is the old school version. So let's start with application load balancers. They're basically best suited for load balancing of HTTP and HTTPS traffic. They operate at layer 7 and are application aware. So basically, if you think about your browser and maybe you change your language to, I don't know, French, for example, inside on a website, your load balancer can actually see what you've done, and then it could go ahead and load balance across all the French web servers. Or if you change your language over to English or maybe to US dollars, it can see that you've done that and essentially load balance across the US servers. So that's all we mean by application aware. It can see inside the application, it can see all the requests that you're making. It can see, even the individual HTML, so it can make intelligent decisions. So application load balancers are intelligent. You can create advanced request routing, sending specified requests to specific web servers. So I want you to think of an application load balancer like a Tesla Model X. They look really, really cool. They're super intelligent, and they can essentially do very advanced routing. So like the Tesla does autopilot. Now, network load balancers are best suited for load balancing of TCP traffic where extreme performance is required. And this is a Tesla Roadster. This is my dream car. This is the fastest car ever built by human beings, both in terms of top speed as well as acceleration. So associate network load balancers with extreme performance like the Tesla Roadster. Now, it operates at the connection level. So this is at layer 4. And network load balancers are capable of handling millions of requests per second while maintaining ultra low latencies. So you're going to use this for extreme performance. And then we have our classic load balancer, and this isn't a Tesla by any means. So these are the legacy elastic load balancers. You can load balance HTTP and HTTPS applications and use layer 7 specific features such as X-forwarded for and sticky sessions. So you can still use X-forwarded for and sticky sessions, but it's not application aware. It doesn't do it at the layer 7 level. And we'll come to what X-forwarded for, what that is in a second. So you can also use strict layer 4 load balancing for applications that rely purely on the TCP protocol. And classic load balancers are basically, they're not all that intelligent. You really want to be using application load balancers. Where you would use classic is if you don't really care about how traffic is routed, and if you're just doing basic round robin, then you might want to use classic because it's going to be a bit cheaper. So in terms of errors that you might see when using classic load balancers, if your application stops responding, the ELB is going to respond with a 504 error. A 504 error just means gateway timeout, and this means that your application is having an issue. This could either be at your web server layer or the database layer. It's not the load balancer that's having the issue. It's the EC2 instances just aren't responding. So what you need to do is identify where the application is failing and scale it up or out where possible. Moving on to X-forwarded for headers. So this is our user. They're browsing to our website from 124.12.3.231. That's their public IP address. And they're hitting our elastic load balancer. Now, our elastic load balancer has an internal IP address of 10.0.0.23, and this is being passed to your EC2 instance. And the EC2 instance is logging the internal load balancer's IP address as our user's IP address. And this can be annoying because you might want to know your user's IP address. You might want to be, know where they're coming from. Maybe you've got a whole bunch of users in France and you want to identify that. So you can still get their public IP address, and what you need to do that is the X-forwarded for. So you just need to look for the X-forwarded for header, and that will have their public IP address. So just bear that in mind for your exam. So onto my exam tips. We've got three different types of load balancers. We've got our application load balancers, which are intelligent. We've got our network load balancers, which you're going to use for extreme performance. And then we've got our classic load balancers, and this might be where you want just basic load balancing at the most cost-effective rate. Just remember that a 504 error means that the gateway has timed out, and this means that the application itself has stopped responding within the idle timeout period, and you just need to go and troubleshoot the application, figure out if it's the web server layer or the database layer, and then you have to go in and fix it. So you scale it up or scale it out. And then also just remember what the x-forwarded4 is used for. Basically, it's used for if you need the IP4 address of your end user, you need to look for the x-forwarded4 header. So that is it for the theory lecture. In the next lecture, we're going to go ahead and get our hands dirty. We're going to start using a classic load balancer first, and then we're going to go ahead and use an application load balancer. Do feel free to go ahead and delete your VPC and all the EC2 instances that we did in the last section of the course. You won't need them anymore. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.